Using the frequency domain, the Laplace and Fourier domains, it simplifies the circuit solution. So don't worry that it will be like complicating the problem. No, it will simplify the problem. All right. At the end of this course, you're expected to be able to analyze second-order circuits in phasor domain. Second-order circuits you might have seen in circuit theory, in which there were capacitors and inductors. So when we have capacitors and inductors, they become second order. Analyze circuit using Laplace transform. So as I said, we'll be using frequency domain to solve the circuits. You should be able to solve the circuit using Laplace transform in frequency domain. You can analyze the frequency response in series and parallel circuits. This is where the network comes in, and differentiate between different types of filters. This is the most important, most interesting part, I would say. Frequency response, whenever we see the word response, it means it is a response to a particular input. Maybe you remember step response, impulse response. Step response is the output, that's the output response of the system when a step is applied as the input. Similarly, impulse response is the response to impulse. Frequency response is the response when we apply a source with some frequency. So sine, cosine, something like that, step, or square wave or triangular wave, could be anything. Then we can do simple manipulation, or like combining together to different to make filters. Whenever we talk about frequency, we can talk about filters because, for example, let's say we are working on a particular system in which there we need a particular frequency, but you know that there is always noise added to different signals. So we need to remove those noise using filters. So filter actually filters out
Hello.
So your mic's muted.
Okay, what was the last thing that you hear from me? What was the last thing that you hear from me? Do you want me to repeat anything? In general, these are basically the course outcomes. I can repeat if you want. Let me know. Anyone?
So start from the fourth point now.
Fourth point, okay.
Yeah, thank you.
Apply Fourier series and transform. Thank you. Apply Fourier series and transform. As long as the source is with the frequency, and with frequency it means it's periodic. It repeats. The frequency comes in when there is some cycle with a period, and also if it's like with a frequency like this, a sine wave, it's okay. But sometimes it's just pulse, just one pulse, square. I should use my. Okay. So if it is like sine wave, it's with the frequency. But what if the signal is just a pulse? Not too good, but it's not periodic. So there we will be needing Fourier series. Okay, so you have to differentiate when to apply Fourier transform, to apply Fourier series, and finally determine the parameters of two-port network. So it's like looking at an appliance from the input, that the plug that you plug in, and the output. What's inside is you don't see. So some people get confused with it, but it's like, you know, ah, my God, too bad. Amazing. Don't worry, this won't be the case because I'll be using another device for the lecture. This is just a laptop I'm using right now. Maybe I'll take a break and come back again with the new. So a box. Okay, and this is the input, and this is the output. Okay, so what's inside, we don't know. We just apply a voltage, we get some voltage or current, and we go for power. So it's like much easier compared to the normal circuits. So don't worry about it. Huh? All right. So when we talk about all this, we're talking about node, mesh, Thevenin, Norton, superposition, all of this, and all of them in frequency domain. So it will be fun to see everything in frequency domain. It's not natural for us because naturally we are familiar with time domain. But trust me, solving circuits or systems in frequency domain is much easier. Let me give you a nightmare. If I'm applying a sine wave here, and suppose there is a system here, and we want to find the output, the nightmare will be to get the output for this particular input for the system. Normally, in time domain, you have to apply convolution. Okay, I'm sure many of you will be getting shivers by hearing the word convolution, that how to apply convolution. You know, like flipping and sliding and all this is like very messy in time domain. But I hope you guys remember that in frequency domain, anything in time domain which is convolution comes as a, can anyone say it? The magic word? Can anyone say what's convolution in frequency domain? Anyone? Guys, I hope my mic is not mute again. Not mute. Can maybe let me see. Okay, who came the list? Okay, Sharif, you came the latest. So I'm asking Sharif directly. Sharif, what's convolution if it is seen in frequency domain? Can you hear me, Sharif? It's okay.
I don't really remember, so sorry.
Okay, Sharif doesn't remember. Okay, where is the list? Okay, Arif, your mic was broken. Now it is fixed, so for sure you can speak. Arif, Noor Arif, no
Hello,
subject.
sir.
Yes. What is convolution in frequency domain?
I also don't remember, sir. So
Okay,
sorry.
now anyone who remembers get 0.5 marks for their coursework marks.
Multiplication, sir.
See now everyone say, who is that? HT. Who is HT? H. Who's okay? Hang. Okay, Hang Ching Tian. Right?
Yeah, sir, it's me.
Okay, multiplication. So good Hang Ching Tian. We call you Hang or Tian?
Yeah, you can call me Heng. Either
Heng.
one is well.
Okay. So anything in frequency convolution in time domain, if we apply a sine wave here with the system and we want to find the output, normally in time domain you have to convolve those terms. And I'm sure that was one big nightmare for your signal and systems course. But in frequency domain, it becomes multiplication. And that's why it all becomes much easier in frequency domain. And we will see that how simplified it will be. Just to recall two things. One is convolution. Second one is differentiation, derivatives. So with the derivatives in time domain will become, we just added s for Laplace, just multiplication once again. So it's much easier. So trust me, it will be easier if you try to grasp the basic concepts from signal and systems. All right. Any questions so far? 5, 4, 3, 2, 1. Okay. Assessment distribution. We'll be having two tests, 20% each. Tutorials, assignments, and quizzes. Actually, I should have put tutorials, assignments, quizzes first and then tests. Reason being, I normally keep tutorials as the basis for the assignments. Actually, they're the same. And these will easily prepare you for the quizzes, and all these will prepare you for your tests, and all these components will prepare you for the extended assignment or assessment, the final exam. So this will be like all, since we are in this pandemic situation and we're not having face-to-face, so everything will be like this. All right, the textbook that I'll be following is Fundamentals of Electric Circuits, 5th edition, and it's basically a very good book, and I hope you can easily find it online as well. As I said, yes. Like basically, oh, okay, this is, I thought, how do I pause it? This card. Okay. Did you hear the voice? This guy's voice? How do I remove it? I don't want this to play. Okay, because this was just for the video. I thought somebody was asking something. It was myself. Circuit theory is required by the system, by the university, but in order to get a good grasp of the course, signal system is also required. And students need to have a grip on the circuit laws and theorems and fundamentals of Laplace and Fourier transform. I already mentioned that before. It will be online lectures on, I should change it to Microsoft Teams because this wasn't working on ULearn because of the delay. So as I showed you before, I will be using whiteboard to demonstrate the circuit analysis, so like a real face-to-face class along with PowerPoint slides. I'll be taking a break, maybe 5 minutes break. You can also take a cup of tea after this slide, and I'll switch to my other device. I have this Microsoft Surface. Let me show you. I'm turning my camera on again. Maybe you can see the camera instead of, how can I make it full screen for you guys? Can you guys see my face? So basically, this is the device that I'm using, and most of you already know this thing, okay? And this comes with this pen, so I can write on it. And the good thing is I can detach it from this, and I can like write on it as if it's a pad or something. So for you, it will be appearing as the whiteboard. Okay. So I'll move to that this device after this one. So maybe we take a 5 minutes break here. Okay. Is it okay? We come back right now with me is 9:03. Okay, we meet at 9:09. All right.
Okay.
Yes, sir. Okay.
Okay. So I see you
Okay,
guys
sir.
at. Stop recording.